Hello everyone and welcome back to the channel. Today I want to start a series to analyze the Zloader malware. I currently don't know how many videos will be in the series. I want to start from the very basics and go as deep as possible. Before we begin, I wanted to share that I recently created a malware analysis course. The course consists of 10 hours of core material which includes slides and labs as well. The course starts from the very basics and it will guide you through the whole process of the malware analysis. I will leave the details of the course in the description below. With that, let's dive into the subject of the video.
So here I am in my virtual machine. I have this folder open in front of me called Zloader. We will start off with the analysis of the information 03.26.doc. So I will run the command olevba /information 326.doc. And this has printed a lot of stuff on the screen. Let's start going back and see what we find here. All right. So this last output is what is going to help us with the analysis. Firstly, we see that there is an IOC here. This is the same IOC that we are going to find during our analysis as well. And if we start going up, we see that there are some base64 strings, hex strings, reg read, str reverse call, wscript.shell, shell, file copy, print, output, open, auto open, etc. etc. All right. Now I will show you where we can extract this IOC from, and then we will also extract this IOC manually from the macros as well. So this is where the IOC can be extracted from, this long string and this function. This function is actually part of an HTML document which is dropped by the macro itself. And this function is part of that HTML document. And if we look at this parameter that is passed to the function, we can open it up in CyberChef. Open up CyberChef and then try to analyze this long string. We'll put this here. Let me just make it a bit bigger. Firstly, we will reverse it. So reverse this, and then we will see that it automatically gives us a hint that if we convert this from hex, we get this IOC. All right. So now let's move on to our Windows Analysis VM, where we will analyze this macro in further detail using the hints that we saw over here. So here I am in my Windows virtual machine. I will start off with the analysis of this information _3.26 document. I will double click to open this document. Go over to the developer tab in Visual Basic. We will go and review the macros. Go to the module. We're looking for the auto open. Let's go to this main function called definitions. And our general approach to analyzing macros is to replace all the execution lines with logging lines. So here is an execution line we're interested in. Here is an execution line which is most probably the final payload execution. So I will comment out this line and I will say here debug.print, and there will be another debug.print, and in the first one I will say print this value, and in the second one we'll print this value. All right. And we're interested in this file copy as well. I will not stop this file copy. I will just say that I want to print this value because this ALG81 is already getting printed here. So debug.print this, right? Control S, save everything, close it, close this. And now we will enable the content and we'll go back and see what happens in the VB macros. All right. So here we are in the immediate window where we can see our debugs getting printed. We can see that the first value, which is hxxps, is mshta.exe, which is getting copied over to microsoft.com in the program data folder. And the other file that is getting executed by this line is microsoft.com and index.html. So mshta.exe is being used to launch index.html. All right. So now let's go and look at the index.html. Index.html is also here as part of our copy in the zip file, and it is also there in the C program data. Firstly, let me go and remove these files from C program data. So before I forget, so these two files were copied by the macro. Let's go and delete them. Go back to our zip file. All right, I'll go close this and close this. All right, so let me open up Visual Studio Code. We will start looking at index.html. And in index.html, we can quickly see this very long content here. And this is part of the paragraph here, and the ID is content. All right, so let's move past this. And we'll see some interesting bits here. Let me make this a bit bigger. All right. Okay. So if we start going down, we can see that the content is being accessed here. WScript shell object is being created here, so that's fine. This is our long string, which we saw was the IOC that we extracted. So we'll start going backwards from here. This function call is interesting. This function call is getting created here from AQHV6, and AQHV6 is basically created by regread from AQJIF8. If you look at the AQJIF8, it is getting written here, and this is the inner HTML of AJZIF. And if you start going up AJZIF, we can see that this is actually this content, which is the large content which we saw there. All right, so let's take a copy of this content, put it in CyberChef, and start doing some analysis on this. So I'll take this. Copy it till here. I'll open up CyberChef. Put this here. And after that, let's start seeing what kind of other things are being done to this. So get element by ID, inner HTML. And I think firstly, this text is being converted from hex. So let's convert this from hex. We see all this text here. In this text, we see that BYKJ is being replaced by empty string. So let's do that. Let me copy out the string. And we'll say replace. And we have our final JavaScript function here. I'll copy this out and put this in a new document. Control S. And this is stage2.js. All right, so here we're going to fix up this JavaScript document by replacing semicolon with semicolon and \n, which is the new line character. We want to use regular expressions here. We don't want to take action in the index.html. We only want to take action here. in stage2.js. So this is fine. The action was taken. And now we see that new lines have been added. All right. If we start going up and start doing a quick analysis of this document, we can see that HTTP object is getting created here. ADO-DB stream is getting created here. We see that the temp path is being picked up here, and this path is being used here to create a temp.dll. And we will also see that this AXOTG is being used here to get this path from U. So U was the path that was being passed here. We can see that the new function was created with two parameters, U and C, and U is the first parameter. So this parameter is actually being passed to the function, and after some fixing up of this parameter, it is being used to get a file from this path. And then we can see eventually, after all this happens, the file is going to be saved here as well. Let me find that part. Save to file. And then that file is getting executed here via redserve. All right. So basically redserve is going to be used to execute this temp.dll, this one. All right. So that's fine. We can start off with the analysis of this temp.dll as well. So let me now close this and close this as well. All right, so now we will start off with the analysis of the temp.dll. We can see the persistence schedule task here, and we can see that DLL register server is being called. So we will call this in a similar manner with run DLL32, the DLL file, and DLL register server. So I'll open up x32dbg, file, open, and in the change command line, I will go and fix the path, which is temp.dll here, and make sure this is DLL register server. Press OK. I will clean off all the breakpoints. And in the options, I'll go to the preferences, make sure DLL entry and DLL load are set as well. Press play, play. And now we are at the entry point of temp.dll. We see we don't have any more breakpoints. All right, so we'll start off with putting here some breakpoints. Control G, virtual alloc, go to the one in kernel base, press a breakpoint on return 10, BP virtual protect, BP write process memory, BP create process internal W, BP NT create user process. And I will explain why I'm putting a breakpoint on this API call as well. So these are the breakpoints on the APIs, and we can now continue our execution. Play. All right, we have a breakpoint hit on virtual protect. We're not interested in this one, so press play again. We have a breakpoint hit on virtual alloc. Right click here, follow in dump 1. Press play again. Follow in dump 2. Press play again. Follow in dump 3. And we'll press play again. And now we see M8Z. Now, whenever we see M8Z, that is an indication that APLib is being used to compress the executable. We'll right click on this, follow in memory map, right click, dump memory to file. and we'll save this on our desktop in our Zloader folder. Save. Now we'll open up this DLL in hxd and we look for DOS mode. So here we have our PE header, which is the unpacked PE. So we can delete everything before this. Delete and save this. Now we can open up this DLL in PE Studio. And we can see now that the exports are visible and we can see DLL register server. If we open up the previous DLL, which is the temp.dll in PE Studio, we will see that there are no exports visible. You will just see that there are no exports visible here in this DLL as well. See, there are no exports available here. Now, the next part of this execution is a bit tricky. Zloader uses shellcode to start execution of the DLL from the middle of the DLL or somewhere in an unknown region of the DLL. It does not start execution from the DLL register server. So we have to find out what is the entry point. Therefore, we have to continue execution here. I will first go ahead and remove the breakpoints from virtual protect and virtual alloc, and then we'll continue execution. This will take a bit more time. I will start the execution and then I'll wait for the breakpoint of NT user process to hit, and then I will resume the video. So press play here and wait for the hit on the NT create user process. So now we have the breakpoint hit on NT create user process. Let me go back to the call stack and I'll go and look for the place from the temp.dll where this was called, and it was called from here, this call to call EAX. I'll put a breakpoint here and press play. And now we can see that actually the process which was created was msi-exec.exe. Now I said that I will explain why this call to NT create process, NT create user process is being used, and that is because the Zloader tries to bypass the call to create process internal W and goes directly to call the NTDLL level function. And if we go and look at the kernel base.dll in IDA freeware here, we look at kernel base c:\windows system32 kernel base.dll. Press OK. Save it in the documents, that's fine. Press OK here again. We'll just wait for IDA to analyze this file. We will look for our function create process internal W. We go here and press F5. We start going down, we'll see that there is a call to NT create user process. NT current peb. This one. NT create user process. So basically what the malware is doing is that instead of calling the create process internal W, it is going directly to this NT level call and bypassing this internal call here. All right, so let me close this. Now we will see the injection take place where it will start writing some code into the MSI exec process, and we'll review that as well. So let's play here. We have a hit on write process memory. Let's see this in MSDN. So I will open up Edge. In write process memory, we're interested in the third parameter, which is the buffer that is being written. And the third parameter here will be 1, 2, 3. So right click on this, follow dword and current dump, and we can see that this is some kind of an encrypted code. So that's fine. We'll continue with it. This is the second write process memory. Again, 1, 2, 3. Right click, follow dword and current dump. I'll move this dump to 4, current dump. And we can see that this is some kind of a shell code. If you look at this in disassembly, we can see that it starts with no op bytes. So any place where we see code starts with no op bytes, that means that this is shell code. So let me go and fix this again. Now, the way that we are going to handle this is that this code is going to basically be used by the malware to decrypt this payload and then start execution. So in order for us to go and debug this code, we will replace this code with a jump to the same line. So in order for us to have a jump on the same line, the code is EBFE. So I'll replace this with EB and FE. And right click this and look at the disassembly. And we can see here that this is a jump onto itself. Jump 309 F734, which is the same line here. So it will continue jumping here. And we will use this strategy to start debugging MSI exec. And I will show you how I do this. So first we start off with replacing this with EBFE. And let's look at our breakpoints here as well. All right, so here we need to put another breakpoint on resume thread. All right, now we'll press play again here, resume thread, and the DLL should now stop execution. Now we will attach to MSI exec process. And we see that the MSI exec process is halted here and it is continuously in this loop. Now, in order for us to continue execution here, I will have to put a breakpoint here. So let me go and put a breakpoint on this set hardware on execution. If we put a normal software breakpoint, this will bypass us, and I will show you this. In fact, let me not put a breakpoint here. Let me put a breakpoint here. This will be a hardware breakpoint, and I'll put a software breakpoint here just to show you guys what happens. So F2 here. And now I will change the EIP to the value of 02. Press OK. And we see that although this software breakpoint was hit, what usually happens in my experience is that this software breakpoint will not get hit and the hardware breakpoint will get hit anyways. So that's fine. We can use both of these things, but I prefer to use a hardware breakpoint in this specific situation. Now, this is the code that is going to decode our encrypted payload. Let me start going down. And we see this value being moved into ESI. If we right click this and follow this value in dump, this is exactly the code that we saw, the encrypted code that was being written to this process. So that's fine. We'll start going here. And we have a loop here. After this loop ends, let me put a breakpoint here as well. So we can see that while this loop is executing, this file is being decoded. We can see already that the first 2 bytes have been decoded to MZ. If we start continuing, we see that this whole file will be decoded as a new PE file. So I'll press play here. All right. And if we press play here, we can see that the file is jumping to 295CA20. I will take this jump, step over, 0295CA20. We have to remember this. So right click, copy selection, and I'll save this in a notepad document. All right, so this is done. So I think this is a good point for us to stop here. This brings us to the end of part 1 of the analysis of the Zloader malware. In part 2, we will continue off from here, where I will show you how I use this entry point to statically analyze the Zloader malware. So thank you very much for your time, and I'll see you in the next video.